control. With this machine, you can expect lower part cost and improved quality. After the first piece, operation is automatic. Tape controlled, it has the ability to extend the benefits of automatic operation to low volume production. Important also is the fact that this machine achieves full automatic operation with minimum complexity. The rotary storage rack holds 15 tools. They are changed in just 5 seconds and may be selected at random. This permits reusing tools or skipping tools. The tool changer paces operation, putting the machine in charge of the cycle time rather than the operator. There are 20 stops to control spindle depth automatically. Stops may be tape selected at random, permitting one tool to be used with several stops, or one stop to be used with several tools. The numerical control system coordinates production. All controls have automatic, semi-automatic, and manual modes of operation. Thumb wheels are for manual input. There's a full range of 0 offsets plus infinitely variable speed and feed selection. It's easy and simple to write tape programs. The programmer simply jots down what he wants the machine to do. He programs the work directly from the engineering drawing. The data is then typed on a machine that simultaneously punches the tape and produces a written set of instructions. People can read the program, and the machine can read the tape. A correctly prepared tape prevents damage to machines, tools, or part. Tapes can be used over and over. They are easy to store with the written program for future use. Tapes assure part consistency between runs, thereby reducing the cost of subsequent operations. Tapes produce automatic operation. Tapes reduce cycle times. Tapes make it possible to handle more complex parts than are practical on manual machines. With the tape and written program, setup is extremely simple. The tape drops into the reader at the console. The prescribed tools are set in the rotary storage rack. They are placed in the holders according to tool numbers. Being in an inverted position, they don't interfere with the workpiece. A wide variety of fixed and adjustable adapters are available, permitting the use of standard cutting tools. Parts to be machined are clamped in fixtures on the table. Various types of inexpensive jigs, blocks, and quick locks can be used. Setting up a job is easy. The written program, which corresponds to the machine language of the tape, lists the information in steps or blocks. A typical block contains X and Y table location, the tool number to be used, and in the case of the 2-axis machine, the Z number indicates which depth stop will control the spindle. These settings permit the originally selected information to be automatically recalled on subsequent pieces. In this case, the first tool is a milling cutter. With the machine in setup position, the operator lowers the spindle until the tool just touches the work. The spindle can be run down by the hand wheel or from the console. A scale on the front of the machine reads the spindle vertical location in inches. The rapid approach stop is set to this position. The feed stop is then set to depth and a trial cut taken. If required, minute corrections for depth of feed can be determined by micrometer head or other inspection methods. The feed stop micrometer is adjusted accordingly. The upper stop controls the spindle rapid approach, while the lower stop regulates the full depth of spindle feed travel. The feed stop has a micrometer barrel adjustment for very accurate settings. Depths can be held to plus or minus 1,000. Thus, by setting depth of traverse and feed stops, the operator has completed one station setup. This normally requires 1 minute. The mill cutter is replaced, the tape is reset, and the milling cut continued. The slot being milled in the steel bar is 2 inches wide and 3/16 of an inch deep. Although this is a heavy cut in tough material, feed is 8 inches a minute. The table moves automatically to the next milling position in 3.5 seconds. Sturdy construction of the machine, the spindle, and the table assures table positioning accuracy to 1,000. Repeatability is 0.5. After the slots are milled, the tape control system automatically replaces the cutter with a 3/8 drill. Time for tool change, 5 seconds. During setup, the stops of all the tools are set. After that, they don't have to be adjusted. The machine automatically drills 8 holes in the block. Exact hole positions have been programmed into the tape. Hole locations in relation to each other is within plus or minus 1,000th or less. DC motors driving ball screws position the table. The reliability and speed of our table movement and clamping is proven on our circuit board drilling machines, which position and drill as many as 60 holes a minute. The next operation is threading, so the machine changes the drill for a tap. Fast, accurate tapping is achieved with our reverse motor tapping method. This means it's unnecessary to use a reversing clutch mechanism to reverse the position of tap rotation. Instead, the machine spindle itself reverses. Even more important, no special extending type tap holders are required. The spindle simply follows the lead of the tap. This is due to our special floating spindle used in the tapping mode. The sensitivity of the floating spindle is proved by the fact that we regularly re-enter a tapped hole without damaging the thread. For example, we will re-enter this hole twice more with the tap. Then check with the test bolt. The re-entering feature is a must for extremely accurate tap depth settings. It's just as simple and routine to bore as it is to drill or any of the other operations on the machine. The tool is changed automatically. The table adjusts to exact X and Y axis position automatically. The spindle rapidly traverses automatically, then shifts to correct feed and speed automatically. The tape is in full command of the cycle. But the finest control equipment can't produce accuracy in a finished part if the machine itself isn't built to the highest quality standards. Our rugged design, our careful manufacturing and assembly account for our accurate machining. An example is the fine finish of this bored hole. There's plenty of power to operate this 1.25" drill. Drilling, tapping, milling, boring, they're all performed equally well and equally fast on this numerically controlled machining center. All that has to be done to produce additional pieces in the lot is to load and unload and use the cycle start button. 41 separate and distinct machining operations have been performed on this steel block. Complete setup time for the first part is 1.5 hours. That's just 2 minutes, 12 seconds setup time per operation. Additional pieces will be machined automatically, exactly like this one, in just 15.25 minutes. Here is a cast aluminum mounting plate. Programming time, less than 2 hours. Setup time, 54 minutes. 10 tools are used. Machining time is 22.5 minutes. 2 parts are on the table. The first operation is milling a slot completely around the plate. The head is stationary. Only the table moves. Feed rate is 20 inches a minute. And because of its plain bearing design, the table has excellent rigidity. Box-type ways are used, the type normally found in milling machines. The second operation is spot drilling. As 30 holes are to be drilled, rapid table positioning is important. It doesn't take long. X and Y movements are performed simultaneously. This operation is especially fast when you consider that the table clamps itself solid during drilling. Yet for all its speed, tolerances between the center lines of the 30 holes are plus or minus 0.02. 11 1/8" holes are drilled around the outer circumference of the plate. These holes are tapped complete after drilling. 19 1/4" holes are also drilled complete. These larger holes are then counterbored, some to a depth of 1/8 inch, some to a depth of 1/4 inch. 58 separate operations are performed in 22.5 minutes. This averages just over 23 seconds in operation, including tool changes. The production run is of such quantity that it is economical to work both right and left-hand sides of the table. While a plate is being machined on one side, the other side is unloaded and a new plate set in the table holding fixtures. It's all programmed into the tape. All the operator has to do is load, unload, reset the tape, and lubricate the tap. The importance of the numerically controlled table to fast, accurate machining can't be overemphasized. The square gibs on both axes are air-clamped against the boxways, providing a solid machining base. The wide span between bearing surfaces produces extremely flat surfaces for milling. Accuracy of production is assured, scrap pieces are eliminated, and 3 pieces are now machined in the time formerly required to do 1. To retool and set up for this cast iron T-slot block took just 29 minutes. Programming time was 1 hour. 4 blocks mount on the table. Production time for each block is just 3 minutes, floor-to-floor time. This job is scheduled once a week when 70 blocks are run off in 4 hours and 9 minutes. The short lead time reduces inventory. There are 4 operations, 2 on each side of the block. Milling takes place on the left side of the table. Holes are drilled and counterbored on the right side of the table. All machining is under tape control. The operator is kept busy just changing blocks. Formerly, this work was done on 2 machines. A vertical mill machined the 2 slots, while an upright drill made the holes and did the counterboring. With the old method, there was always a problem of assembly because of the variance in dimensions between hole locations and mill slots. Now that the job is done on just 1 machine, there is considerable time savings, not only in machining the block, but in assembly as well. Formerly, a high percentage of the blocks didn't measure up and had to be scrapped. Now there is 100% acceptance. In this case, better part consistency reduces the cost of subsequent manufacturing operations. Tooling possibilities are many. This is an example of just one. An air indexing chuck is used in the production of brass oil injection mounting rings. 4 holes, 90 degrees apart, are spot drilled, then drilled through. The programmer had no trouble tying in the sequence of the indexing chuck with the numerical control machining. The tape forms a continuous loop, so the operation continues uninterrupted as long as there are parts to drill. The tape paces the operation. The machine is in charge of production. It's always the same, a feature that simplifies scheduling and permits accurate cost estimating. Through the ingenuity of the programmer and the Edlin-Matic, 10 mounting rings are now turned out in the time formerly required for 1 ring. This aluminum junction box has holes drilled from 2 sides that meet in the center. Four junction boxes are mounted on the table, a pair on each side. While machining on one side of the table, boxes are changed on the other. 9 tools are used in all. Complete setup time is 54 minutes. That averages exactly 6 minutes a tool. There is one long drilling operation of 4 1/2 inches with a 5/16 inch bit. Another hole is drilled 3 1/4 inches deep. Holes are then tapped for pipe fittings. Each tool can be made to operate at its optimum efficiency because of independent speed and feed control settings. This feature is of growing importance with the ever-increasing demands for parts machined to closer tolerances and having improved surface finish. A programmer very quickly learns the best arrangement for part machining to tie in with production schedules. All sorts of clamping devices are available. There is a variety of automatic devices and chucks, plus conventional manual clamps. Because of machining capability like this, a junction block is machined complete in a floor-to-floor time of 10 minutes. That's really fast when you consider each block has to be mounted 3 ways on the table. This aluminum limit switch post requires milling, drilling, reaming, and tapping. 8 tools do 16 machining operations. First is milling. 4 cubic inches of aluminum are removed in a minute with ease and accuracy. This is truly a machining center. It is one piece of equipment that eliminates a variety of horizontal and vertical mills, radial and upright drills. By handling a number of operations with one setup, accuracy between pieces is achieved. Rapid production is assured because all machining, tool changes, table movements, and spindle movements are under tape control. To lessen the problem of zero drift in milling and boring operations, heat-producing motors have been placed outside the major castings, assuring accuracy of part production. After drilling, a hole is immediately reamed. Automatic tool change allows the operator time to switch the coolant out of the way so he can lubricate the reamer. Again, automatically, NC operation traverses the table and changes the tool for the machining operations on the other side. This gives the operator time and space to change pieces to keep production rolling. On a wide variety of jobs, time studies have shown that on the average, 2.5 pieces are machined floor to floor in the time it formerly required to do 1. In addition, the average saving on jigs alone is in the area of $200 per fixture. And with 100 jobs, which is not unreasonable, jig savings will pay for this numerical controlled machining center. There are hundreds and hundreds of large lot and small lot production jobs now being done on a variety of mills and drills at a sacrifice of profits. What's your situation? Shouldn't you be in a more competitive position? Maybe this small selection of pieces will give you an idea of where and how you can improve your profit picture, can save time and actual money by doing this type of work on an Edlin machining set.